In the last few videos, we've been focusing on integers and binary. For this video, though, we're switching focus back to decimal to try to understand more about division. Let's start with a simple question. At the time I'm making this video, it's 10 o'clock in the morning. What time will it be 100 hours from now? Pause the video and see if you can answer that question. If you can't figure it out, that's okay. Just give it a try and see what kinds of tricks or methods you come up with. Here's one way to think about this question. 24 hours from now, it will be 10 a.m. again. And so every time 24 hours passes, the time on the clock is the same. How many 24-hour increments happen in the space of 100 hours? Well, 1 day is 24 hours, 2 is 48, 3 is 72, and 4 would be 96. If I went forward one more day, this would be over 100 hours, so don't do that. 100 hours is 4 full days plus 4 extra hours. And it's really only the 4 extra hours that matters here. In 96 hours, it will still be 10 a.m., and in 100 hours, it will be 4 hours after that, or 2 p.m. What does this have to do with division, you ask? Well, when we divide one integer into another, we're not performing a mysterious algorithm. We're actually doing something very simple that kids do all the time. Look, for example, at the problem 22 divided by 3. What this is asking is really, how many groups of 3 can I make out of 22 things, and how many of those things would be left out of a group? In this case, you can take 22 items and group them into 7 clusters of 3, and there will be 1 left over. So we say that 3 goes into 22 7 times with a remainder of 1. The quotient, 7, is the number of groups, and the 1 is the number of items that don't go into a group. So when we asked what time it would be 100 hours from now, we thought about it by asking how many groups of 24 hours can we make out of 100, and how many hours would be left over. The answer was that we can make 4 groups, and 4 hours are left over. In other words, we solved the problem by simply dividing 100 by 24 and focusing on the remainder. Now notice that division in this way of thinking about it is really not a separate operation at all, but just a combination of multiplication and addition. When we divide one number by another, we ask ourselves how many times, literally times, we need to cluster and then add on the leftovers. And notice that the leftover has to be smaller than the thing we're dividing by. If it were larger, then we could just form another group. The exact way of expressing this idea that division is just multiplication and addition put together is in a mathematical fact known as the division algorithm. And it states that given any two integers a and b with a non-zero, there exist unique integers q and r such that b is equal to aq plus r, and r satisfies the inequality 0 is less than or equal to r, which is less than a. We can see this in the examples we did above. This way of thinking about division is extremely powerful, especially in computer science, since it means that division doesn't require new operations, just multiplication and addition, which computers are very good at doing. There is some mathematical language in the division algorithm that needs unpacking. First of all, notice that like an algorithm, there is input, 2 integers, which we call a and b, and we stipulate that a doesn't equal 0. Then there is output. 2 integers we call q and r. Here, q stands for quotient and r means remainder. The division algorithm states 3 facts about q and r. First of all, it says that they exist. Regardless of the integers, as long as we aren't dividing by 0, there always will be a quotient and a remainder. This is a little like the requirement we place on every algorithm that as long as we give it valid input, the algorithm should produce a valid result. Then it says that the quotient and remainder are unique, meaning that there's only one pair that will result from the division process. It wouldn't be a very good algorithm if one set of inputs produced one set of outputs one time and another set of outputs a different time. Then finally, it places the size restriction on the remainder. The remainder could be as small as 0, but it must be less than the thing we are dividing by. Let's actually think about why the division algorithm works. Let's say that b is bigger than a. So we have a bunch of things whose precise number is b that we want to package up into groups of size a. Let Q be the number of groups and R the number of things that are left unpackaged. We're going to start a process with Q equal to 1. This packages up A of the items, but there are a lot left over. In fact, there are B minus A of the items left over. So we're going to increment Q up to 2, which leaves B minus 2A left over. And notice that B minus 2A, while still non-negative, is less than B minus A because you're subtracting a larger amount from B. In fact, every time we make a new package, we increase the Q by 1, and we are removing A of the items. And that decreases R while still keeping it non-negative. Since the sequence of R values here is strictly decreasing and consists only of non-negative numbers, at some point you are going to reach a point where you cannot package up any more of the items because the R is as small as it can get. In other words, we know that regardless of what we start with, as long as the A is not 0, this algorithm will always terminate. And when it does, notice that you have R equals B minus AQ, which in other words is B equal to AQ plus R, and R satisfies the inequality 0 less than or equal to R less than A, because if R were bigger than or equal to A, we could just make another package. The Q is our quotient and the R is the remainder. We'll skip explaining why these two numbers are unique, but you're encouraged to think about what would happen if you had two different values of Q and two different values of R that produce the same packaging that this algorithm does. So what the division algorithm says, basically, is that integer division is more or less just repeated subtraction. We start with a number we are dividing and a number we are dividing by and start subtracting off the second number over and over until we can't do it anymore without entering negative territory. And that's why long division works. When we do long division, all we're doing is subtraction in chunks. First seeing how many times we can subtract off from the largest place, then subtracting that off and seeing how many times we can subtract off from the next largest place, and so on until no more subtraction can be done. So the division algorithm is a mathematically precise way to express how we do long division without actually doing any of the long division. There's an important application here as well to an operation that's critical for modern computer applications. That operation is called the modulus operation. You probably didn't learn this in school, but it's both simple and very useful. We often use the percent symbol to denote it. Here's how it works. Given two integers a and b with a not equal to 0, this expression here, which we read b mod a, is the remainder that is left when you divide b by a. For example, 37 mod 10 is 7, because 37 divided by 10 is 3 with a remainder of 7. And 100 mod 24 is 4, because as we saw earlier, 24 goes into 100 4 times with a remainder of 4. Similarly, 22 mod 3 is 1, because 3 goes into 22 7 times with a remainder of 1. One technical note at this point, the way we're defining the modulus operator here as the remainder that's left over after division only makes sense if neither A nor B are negative. If one of these two is negative, then the long division isn't defined in quite the same way as when they're positive. This is a glitch in our definition of the modulus operator that we're going to have to fix later, but we're going to keep it simple for now and just go on working with merely positive numbers only, although we don't exclude the B from being 0. The modulus operator has thousands of uses, including date and time calculations like we started this video with. And for example, it is a central tool in cryptographic methods that secure your online data. So in this video, you learned that division can be thought of as repeated subtraction, and this notion culminates in the division algorithm. And you also learned about the modulus operator and how it works. There's just one video left in this whole module, and that brings us back to binary to think about how negative numbers are represented. See you there.